Today in Honors Chemistry, we're going to start Chapter 4, the structure of the atom. And so I'm going to go straight to Roman numeral 2. Roman numeral 1 deals with the discovery of the atoms, subatomic particles, and scientists responsible for that. Okay, so the atom has two main parts. You have the nucleus and you have the orbitals. The nucleus will contain protons and neutrons, and so I'm going to put the symbol P with a superscript positive for a proton, and N for a neutron with a superscript 0. This simply means that the proton has a positive charge and the neutron is neutral, it has no charge. And the nucleus will contain most of the mass of the atom, because protons and neutrons are each assigned a mass of 1 and electrons basically are assigned a mass of 0. Outside the nucleus you'll find the orbitals, and this is where the electrons with a negative charge are spinning all the way around and in 3D, and they have basically no mass. Now your book will give you the actual masses of these particles. Then we have the atomic number. So when you look at your periodic table, in the center of each box in the upper center is a number. That is the atomic number, and the atomic number tells us the number of protons that element contains, and it identifies the element. So you have a question, what is the atomic number of aluminum? So you find aluminum on your table, and you notice it has 13 as its atomic number. And then which element has 26 protons? If it has 26 protons, it's going to have the atomic number 26, and so that would be Fe, which is the element iron. Okay. Since atoms are said to be electrically neutral, you can also determine the number of electrons from the atomic number. But specifically, the atomic number is giving you the number of protons. Okay, so here's, you have several examples. If you'll stop for a second and complete those and then join back in. So it says, how many protons does a neon atom have? So you find neon on your table, and you should have said 10. It has atomic number of 10, it has 10 protons. How many electrons does a neon atom have? Since atoms are electrically neutral, if it has 10 protons, then it will have 10 electrons. An element with the atomic number of 6 has how many electrons? Well, if it has the atomic number of 6, that means it has 6 protons. Then once again, it would also have 6 electrons. Okay. The next topic is atomic mass. Atomic mass is the number of protons and neutrons in an atom of an element. So here is an example, oxygen-18. This is one of our notations. We'll talk about what everything means in a second. Has a mass number of 18. How many protons, neutrons, and electrons does oxygen-18 have? So you go to your periodic table once again, you find oxygen, its atomic number is 8, so it would have 8 protons. That means it has 8 electrons. To find the number of neutrons, you just take your mass, which is 18, minus the number of protons, which is 8, and so it should have 10 neutrons. If a particular atom of carbon has a mass of 14, how many neutrons does it have? So when you look up carbon's atomic number, it is 6. So if it has a mass of 14 minus 6, it would have 8 neutrons. Okay. Isotopes, atoms of an element. Isotopes are defined as atoms of an element with varying numbers of neutrons. So they will have varying masses. Every element on the table, or almost every element on the table, will have at least 2 different isotopes. However, it does not matter how many isotopes there are for a particular element, the isotopes of an atom will always have the same chemical behavior. So the number of neutrons does not make them behave any differently. Okay, hydrogen has 3 isotopes or nuclides, so a nuclide is a different name for an isotope. And the question is, we have a little table and it's got protons, electrons, neutrons, and then the atomic mass. Now, hydrogen, they gave the different isotopes names. Okay, most elements will not have names. They'll have just different types of notations. So since all of these are isotopes of hydrogen, we know that they all have one proton. And if they have one proton, we know they have one electron. Okay. So now to determine their mass. So I'm going to kind of start at the bottom and work my way up. Tritium, tri means 3. So the tritium isotope will have an atomic mass of 3. The deuterium, a duet is 2, will have the atomic mass of 2. And then protium will have an atomic mass of 1. So if we know the masses, now we can go in and figure out a number of neutrons. So if it has one proton, it has a mass of 1. For protium, that means it would have a 0 number of neutrons. Deuterium, since it has one proton, it would have one neutron to give us a mass of 2. And then tritium would still have one proton. It would have 2 neutrons to give us a mass of 3. Pretty simple. Okay, now most of the elements on the table have isotopes. I just mentioned that a minute ago, and we do not give them names, so we designate them by isotope notation. There are 2 ways we write isotope notation. One is called hyphen notation. Okay. And hyphen notation is simply you write this element's name and then you give it a hyphen. So let's just use the example. I'm just making this up. Uranium hyphen 235. Okay. The other type is called nuclear symbol method or notation. And if I'm not mistaken, I think your book might call it isotope notation. Okay. So it simply is the atomic number is added to the symbol for the element as a subscript on the left, and the mass number is added as a superscript on the left of the symbol. And so if we take this uranium hyphen 235 and we write it in nuclear symbol, we look up the symbol for uranium, which will be a capital U, and we're going to write our numbers over to the left. Its mass is 235. And then you find uranium on your table, and its atomic number is 92, so 92 is the subscript. Okay. Atomic mass is given in units called the AMU. Okay, so I'm going to show you how they come up with this number at the bottom of each element. That's the average atomic masses. So the atomic mass unit is defined as 1/12 the mass of a carbon hyphen 12 atom. A carbon hyphen 12 atom has 6 protons. I forgot my 6 in here. And 6 neutrons, and they have set its mass at 12 AMU. An atomic mass unit is also called a Dalton. However, the atomic masses on the periodic table are not whole numbers, mainly because most elements occur in nature as a mixture of isotopes. So the masses are weighted averages reflecting the percent abundance of each element. So here is your formula for this chapter. Average atomic mass is equal to the relative abundance of isotope 1, whatever it is we're talking about, times its mass, plus the relative abundance of isotope 2 times its mass, plus however many isotopes there are. When doing weighted averages, it's often easier if you'll change the percent to a decimal form. So instead of using 55%, you'll use 0.55. And I'll show you both ways on this problem. You can do whichever one is most comfortable for you. Okay, so it says calculate the atomic mass of bromine. And the 2 isotopes of bromine have an atomic mass and relative abundance of 78.92. And there are 59.69% that have that mass, and 80.92, which 40.31% have that. So we're going to say the average atomic mass equals. Okay, so I'm going to show you 2 different ways. So you're going to say 78.92 times, there are 59.69%, so we'll just say times 0.5969. Just hop your decimal place over 2 times to the left, plus 40.31% of them have a mass of 80.92. So we have 80.92 times 0.4031 equals. You can either put these in parentheses, or what I like to do is I like to write the number above and then add them up. So you have 78.92 times 0.5969 equals. So this one turns out to be 47.107. And then we have 80.92 times 0.4031. So that gives you 32.619. Okay, so we're going to add those two numbers up. Okay, so we get 79 point, and let's just do this to 2 decimal places, 73 AMU. Okay. An easy way to tell if you're in the working this correctly is your masses should fall between the lower mass and the higher mass. Okay, another way of doing this, if you'd rather not do decimal places, you can simply take 78.92 times 59.69 plus 80.92 times 40.31, and then divide that all by 100. Okay. Either way, you'll get 79.73 AMU. Okay, so those are our 2 types of notations. Now, I gave you a little bit more of information on other subatomic particles. You can read through that. If I asked anything about that on a test, it would be a bonus question. Okay. Okay, so nuclear reactions. So if the nucleus of an atom is unstable, and typically that is going to be because you have too many or too few neutrons compared to protons, it can emit radiation to become more stable. In doing so, it changes into another element that is more stable. You might want to add this to your notes. Mass and charge must be conserved. Okay, there are 3 types of radiation we're going to introduce you to. The first type is called alpha radiation. And alpha radiation will emit an alpha particle. And an alpha particle will contain 2 protons and 2 neutrons, and it has a charge of +2. You can write an alpha particle using the Greek letter alpha, which is like a fish, or you could write it as a helium-42. I would write it as the helium-42 because it's easier to see what's going on in your equation that you're going to write. Okay, so let's practice one. So let's say that I tell you you have a uranium isotope with the mass of 242, and I tell you it's going to undergo alpha radiation, so that means it's going to emit an alpha particle. So I would write it as a helium-42 plus. The left-hand side of our equation has to equal our right. So to find this lower number, you go to your periodic table and you look up uranium's atomic number, which is 92. So that means it has 92 protons. Okay. And then we need to figure out what our unknown atom is. And so you're going to add something to 2 to give you 92. So we're looking up element 90, which is, if I can find it, thorium, TH. And then 4 plus what gives you 242? So it should be 238, because 238 and 4 gives you 242. Another type of radiation is called beta radiation. And beta radiation will emit a beta particle, which is a very fast-moving electron. It can be written as using the Greek symbol B, a B with a long tail, or electrons have 0 mass and a charge of -1. Okay, so let's take our same uranium isotope, and let's say instead of undergoing alpha radiation that it undergoes beta radiation. So you put your uranium-242. We know it has the atomic number 92. This time we're going to assume that it's undergoing beta radiation, so I'm going to put electron 0 minus 1 plus, now we need to figure out what it becomes, okay? So minus 1 plus what gives you 92, so that would be element 93, because 93 minus 1 is 92. And so we look up that element. Element 93 is neptunium, so Np. And in this instance, our mass will not change because an electron has 0 mass, so it'd be a 242. Okay. And then our last type of radiation is called gamma radiation. Gamma radiation will emit a gamma ray, which is a very high energy ray that possesses no mass nor charge and is written as the Greek letter gamma. It normally occurs along with either alpha or beta radiation. So usually along with an alpha particle, you're going to also emit an with a gamma particle, you're also going to emit an alpha or beta. Okay, so that takes you through your study guide on Chapter 4. Thank you.